Start recording. All right. So today's lecture portion is going to be focusing on exam one. I hope you guys had a chance to take a look at the question and try to answer as much as you can. Because if you did that work ahead of time, then my explanation will be fairly easy to digest. Okay. For people who did not spend any time to take a look at the exam before, most of this can be a little bit more difficult to digest. Okay. Yep. Go ahead. It'll be next Thursday. Yes, that is correct. So our exam one is next Thursday during the lecture time. Yes. As long as I understand, it's fine. So that means anything that I have mentioned is fine. So you can use C++ notation, you can use the mathematical notation, or you can use the software or a computer engineering notation, or a mixture thereof. Yep. All right. So we are starting out with question number one. Is that font size okay to people in the back? You want it to be a little bit bigger? Zoom in. Let me see if I can do that. Nope. Nope. As long as I understand, it's fine. Not a problem there. Okay, so that's the maximum I can bump up unless I zoom on the tablet side. Is that okay? Is readable? Okay. All right. So we're going to start with this particular question. So read the question carefully. So I forgot to change my glasses. So let me do that. This is one of those fun things that you get to do when you're older. You get to carry multiple pairs of glasses, one for each specific distance that you need to look at things. So when you look at things from different distances, you have to switch glasses. All right. Huh? No, bifocals, limit my. Yeah, exactly. What I really need is autofocus. I think. Sorry? Maybe next update. I think they do have things that have a little knob here, so you can kind of adjust the distance, but they're kind of clunky right now, so they don't work as expected. hmm Well, I mean, before long, I won't be needed in the classroom anymore. It'll just be ChatGPT teaching the class. I actually know a way to do already. I can go to the curriculum of this class, get all the student learning outcomes, and then ask your ChatGPT to derive a overall plan for the semester. And then for each topic in the semester, I'll ask it to generate a lesson plan for the day. And I think everything can be automated already. Anyway, well, I mean, eventually, I think the best thing to do is to have everything totally individualized, right? So, so there's no such thing as a class. There's no lockstepping, in the class. Hmm? You'll pay for something. Whether you call it college or not is a different thing. I don't know. I think at some point, education will be all um, career oriented, which means your employer will be offering the education because they don't want anything else. They just need you to understand how to get their job done. So, I think many, many different directions. All right. So, question number one. So, I'm reading the question right now. In the following space, explain how to conclude the given statement on each line. The explanation on each line can only utilize statements in earlier steps. You cannot change the order of the explanation. To save time, you may reference the number of a statement, which means if you want to reference 1, which is how T2 is defined, you just say 1, and I usually put a circle around it, but you don't have to. However, okay, right there. If you're visual, you can use the long addition subtraction table to visually aid your reasoning. However, I only score based on the following list of explanation. Each line can be explained by just statements already given or explained, comma separated. You do not need to use English to explain. However, please be complete and quote all, but also only directly related statements leading to the concluded statement on each line. So what are the concluded statement on each line? X1 equals to 1 is a conclusion, and that belongs to item number 9. So if there's a later point where you go like, oh, knowing that x1 equals to 1 is one of the many things that I need to deduce something else, then you just quote 9. Okay, that's all you need to do. All right. Since all the bit values are resolved, scoring is based on the proper explanation of the given statement on each line. In other words, all the bits are already resolved. Okay, so you're not here to resolve bits that are unknown, but you need to figure out how to explain how each bit is resolved. So the first 8 points from 1 to 8, those are given to you. Okay, there's no need to explain anything from point 1 to point 8. They're given to you. Now, the other thing that is interesting about this particular question is technically anyone who understands logic can complete question number 1 without even having to take this class, without having to understand what is binary addition or binary subtraction, because all the formula and all the equations that you need are already provided here. They're all defined here. Okay? Now, the only question is how long would that person take in order to answer all of these questions? That's the only question. Okay? That's the only part that is, different when we compare a person who understands binary subtraction really well as opposed to somebody who has not taken this class at all and just starting from scratch by looking at the given from 1 to 8. All right. So given that context, I want to provide that context because I want people to understand that you have everything that you need right here. Okay? You don't need to bring your notes. Everything that you need to know to answer these questions is in the question itself. It is self-contained. Yes. Hmm? In the announcements. Exam 1. Yep. All right, so we'll start with number 9 because 1 to 8, there's nothing that you have to do. So we will start with number 9. X1 equals to 1. Oh, okay, this one is also given because it states no need to explain. This is given. So the only starting point, the actual starting point is 14. Okay, so we move on to 14, and it says the negation of x1 and y1 and d1 is a 0. It's false because of what? Okay, yes. So we are looking at the conjunction being 0, which means if we know at least one of the items of the conjunction is false, then the whole thing is going to be false. So now we ask, do we know anything about D1? Not exactly. This one gives you the equation, but not the actual value. Do we know anything about Y1? Nope. But do we know anything about x1? Yes. So x1 is a 1, which is on number 9. The negation of 1 is false. So that means this point here is false. So that means the entire thing is false. So the only thing you need here is 9. Oh, okay. Yes, because I don't want anyone to just list everything prior to that point. It's like I'll just write 1, 2, 3, 4, 5 all the way to 13. Sorry? Um, then you get partial credit. Yep. 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 8 and 13. That would not be correct because 8 and 13 does not imply that the. Okay, so let me point on the screen here. So 8 is telling you how overflow is defined. 13 is telling you the overflow is a 1, but it doesn't tell you which one is which is false. It does not automatically conclude that the left-hand side of the OR is the one that is false. It doesn't tell you that, okay, and when the OR is a 1, it means at least one side of the OR is a 1. It doesn't tell you that exactly one side is a 1. And it definitely does not automatically tell you which one is a 0. Yes, 9 is the only correct answer here. Now, certain ones have multiple answers. This one only has one single correct answer, which is 9 itself. All right, so we'll move on to 13. So 13, okay, so I just page up here. So 13 says, blah 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 plus, or blah 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 is a 1. So that one has to do with how overflow is defined, and overflow itself is a 1. So let me go back to here. How overflow is defined is 8, and overflow itself is a 1 is 13. So 8 and 13 are the ones that you need for 15. Is that okay? Yes. Let me Okay, can I use, okay, so 9 is x1 is a 1, and then which one again? And 13? All right. Mm, so the question is really is, can 9 and 14 replace 8? That's your question. Okay, so 9 is, x1 is a 1, and 14 is a result of 9. So 9 implies 14. So the question is, can 14 imply 8? And 8 here is the whole definition of overflow. The answer is no, I don't think that can be implied. All right, so I'm going to cross out the answer that cannot be the correct answer. Cross it out. There we go. So moving on to the next one. Q0 exclusive or T0 is a 1. All right, so how do we know that? So you have to understand what that really is, okay? So exactly what is Q0 exclusive or with T0? Hmm? Okay, so 10 is D0. So D0 so 10 by itself is not enough. So you have to look at how D0 is defined, which is number 5. And then you have to look at 10, which says that whole thing is a 1. So it is correct that you need both. So in this one you need 5 and 10 together. Does everybody kind of get the idea of how to get this to work? The whole thing is one gigantic um, logical Sudoku. Yes. No, we do not. T0 is an unknown. Yep. So in these questions, T0 cannot be assumed 0. Because remember, when you did the 3 by 3 adder, K0 is an input pin. T0 is also an input pin. We cannot assume it is a 0. We are trying to explain why Q0 exclusive or with T0 is a 1 using only things that we know at this point, up to point 16. Yep. 5 and 11. 5, 10, and 11. Okay, so 5 is the definition of D0. 10 is the fact that D0 itself is a 1. And then what is the other one again? 11? The answer is no, because so okay, let me just write down the proposed thing here. 5, 10. Are you? But you already include 510. 510 already is suffices. So 5 and 11 or 10 and 11. 5 and 11 are not sufficient. Yep. Well, we are still on 16. Let me get 16 out of the way first. So, are there any questions about 16? Yep. Because 10 is saying D0 is a 1, and then we also know how D0 is defined on point 5. So that means the right-hand side on the equality of 5 has to be a 1. That is the bridge. You need 5 as a bridge so that we know that even though we are given that D0 is a 1, but in order to know that Q0 exclusive or with T0 is a 1, we need 5 as a bridge. hmm So are you guys kind of getting the general idea of how to work on this? It is. It's logical Sudoku. But this one is like the simplified version. This is logical Sudoku light. The one that I used to ask before is I just give you some bits and I ask you, okay, how do we know the rest of the bits? Like I will give you two, and then there will be like 4 or 5 unknown bits, and then you have to figure out, okay, how do I figure out the rest of the bits? This one is easy. This one is giving you, plenty of clues already, in the sequence. Okay, all right. And then later on I'll talk about how to study. Okay, because I can definitely tell that some people are looking at this and go like, I have no idea how to answer these questions. Okay, let's go to number 17. So go ahead. Okay, so the proposed answer is 6 and 11. Okay, so 11 says Q0 is a 1, 6 and 16. Okay, 11 and 16. Okay, so I need to put this down so I can start to erase things. Okay, so the proposal is 11 and 16. So 16 is defining Q0 exclusive of with T0 is a 1, but it doesn't tell us anything about either one. And then 16, 11 is saying Q0 is a 1. So that is correct because if you know Q0, okay, let me point on with my mouse pointer here. So if you already know that Q0 is a 1 and you know whatever one exclusive or with, okay, one exclusive or with T0 is a 1, that you can conclude that T0 has to be a 0. That is correct. So 1116 works. All right. So I think at this point you probably already kind of get the idea that you have to really know the operators. What operators are we talking about? Negation, conjunction, disjunction, and exclusive or. Okay. And then the idea is if I give you just the result of the operator and only one of the values that is operating on, can you deduce with certainty what the other value is? So looking at the truth table will help you. Okay, so remember, everything is coming from truth table. You don't need Boolean algebra in this case. All you need is truth tables, or truth tables. All right, so we're moving on to 18. X0 exclusive or with Y0 is a 1. Okay, so that is Q0. Do we know Q0? Yes, we do. 6 and 12. I think 11 is fine, and then we just need the link from X0 exclusive or with Y0 is Q0, and that would be one of the early ones, which is 6. So 6 and 11 is what we need in this case. Is that okay? All right, moving on to 19. Your y0 is a 1 because, well, we know the exclusive or between those two is a 1, and then we just need x0, so 12, and the one before is enough. Okay, all right. So now we get to 20. So 20 is getting back to overflow. We already know from 14 that one side of the whole thing is false. We know from 15 that the disjunction is a 1. So between those two, I can come to this conclusion. So 14, 15 together is enough to conclude that x1 and the negation of y1 and the negation of d1 has to be a 1. Is that okay? This one is based on disjunction. Okay, the result of the disjunction is a 1. We know one side of the disjunction is a 0. We automatically can conclude the other side of the disjunction has to be a 1. All right, so we're moving on to 21, which is y1 is a 0. No, 20 alone is fine. Nope, 20 alone is fine. Okay, so can is that okay? Is it obvious that 20 alone is already enough to imply that y1 has to be a 0? Because the conjunction involving the negation of y0, y1, sorry, the conjunction involving the negation of y1 is a 1. So that means everything in the conjunction has to be a 1, including the negation of y1. If the negation of y1 is a 1, then y1 has to be a 0. And so 20 is all we need for 21. Yes, I don't care what is x1 because I just know the conjunction. The entire conjunction is a 1. So that means every term in the conjunction has to be a 1. But the only one that I care about is the negation of y1 is a 1, which means y1 has to be a 0. All right. And then the next one is, so at this point we know what is y1. Do we know what is x1? We may not. 9. Oh, okay. So that would be between 9 and 21. So 9 and 21 is fine because I cannot read the previous page. You guys can. There we go. Okay, moving on to 23. So 23 is easy, okay, because 22 combined with the definition of Q1, which is number 4. Okay, there we go. I think you guys are getting the hang of it. Okay, that's good. And then 24 is D1 is a 0. So there are, so what you need to do, what is your thought process? Exactly. So how do we, so there are a few ways, okay, how is D1 involved with the other digits? Well, what we know is Q1 exclusive or with T1 is D1. So do we know Q1 and T1 already at this point? Nope, T1 is not known yet. Okay, hmm? We only know Q1, but um, yeah, so that's not enough. But another thing that can also help to determine D1 is overflow. Hmm? Yep, 20 alone would work because overflow, which or one side of the overflow, which is 20, if this entire thing is true, that means this thing, the negation of D1 has to be true, which means D1 has to be false. So 20 alone can make the conclusion of 24. All right, moving on. Okay, D1 exclusive or with overflow is a 1. So so 13 is 1 because we need that. And then D1 is 24. So between those two, we can come to that conclusion. And then 26, okay? So at this point, we do know what is T1 and Q1. So we just have to quote those two. One is 23. The other one is, um, oh, actually, I take it back. We do not know because it's below it, right? It's T1 is known below it. So we cannot future reference. We can only reference things that are known at this point. All right. Okay. The other thing we can also do is Q1 exclusive of T1 is known as D1, and we know that D1 is a zero. So 24 is. Give me a second. Let me finish this first. And three, I think. Okay. So 24 3 is one way to make that conclusion. And what is the other way? But we're on 26. Okay, can you give me the numbers so I can actually write it down? 12 and 18. So 12 is x0 is a 0, and then 18 is x0 exclusive or with y0 is a 1. I do not see how those two alone can come to the conclusion that Q1 exclusive or with T1 has to be a 0 for the T side. I'm not. Are you talking about, are we still on 26 or 27? So you still need to include more. Yep. So 24 and 3 are the most obvious one because that's just really direct. Well, I mean, if you come up with alternative, I would look into the alternative and see whether it makes sense or not. So that means, from the grading perspective, this one is actually kind of time consuming to grade because what I'm giving you here is one possible set of answers. There are other ways to come to the same conclusion as well. All right, so number 27, T1 is a 1. Oh, that's pretty easy. So 26 is 1, and then knowing what Q1 is, which is 23, is already enough. But you can also use other ways to do it too. So to conclude that T1 is a 1, you can also say, if I know what is x0, y0, if x0 minus y0 it has a carry, then you can refer back. So I can alternatively use x0, y0, knowing those two particular value, plus, okay, x0, where do we know? So 12, and then y0 is 19, and then we have to go back to T1. So T1's definition is 2. So you can also look at these three together and also can come to the same conclusion. So there are multiple ways to get to the same answer, which makes this a little bit harder to grade. All right. Coming to the last one, that one should be pretty easy. Okay, so 25 is one, and then the definition of L is the other one, and that would be number 7. There we go. All right. As I said, this particular question actually does not need you to understand what is binary subtraction because everything that you need to figure out the rest is already in the question itself. But knowing binary subtraction, putting things into that subtract the context really helps. Okay, in some cases. Are we good with question number 1? All right. So maybe I can, in this round of the exam one, instead of asking which two, I will say list all possible ways to make that conclusion. Gi- give me a depth first search of all the possible solutions. All right. Question number 2. You okay? Trust me. Question number 1. I have uploaded this question to ChatGPT. It could get, I would say, probably around 80% of them done correctly, and then the other 20% it just could not figure out. And I even put this up onto O1, the O1 model, which according to OpenAI is a PhD candidate level of intelligence. I know there's O3, but O3 is based on O1. Um, and O1 could not solve it either, not completely. DeepSeek will probably just ask you to ask some go attend a few classes in some Chinese university. But first of all, pay money first. Then we'll give you a link. All right. So question number two. You are given that X is a 6-bit pattern as follows. Okay, 101010 in base 2. So question number part 1 is asking what is VSX6. So that's a well, but you cannot just give me the answer. You have to show your steps. Okay, so don't forget to show your steps. So you can say 0 plus 2 plus 0 plus 4 plus 0 minus, oh, is it? Let me see. Okay, I think I messed up already. This is supposed to be 8. Okay, that's supposed to be 8, 16, and then the 32. And you have to explain because it show your steps, right? That is sufficient. It is sufficient because it shows me that you know what powers are corresponding to the ones and what to do with the sign bit that is different from the non-sign bit. So this would be sufficient. So that would be what, negative 22, I think. Yep. Yeah, that's even better. If you use exponents, it would be even better. Okay. So yeah, that would be fine. Yep. Um, the zeros are here to imply that you know what to do with those particular bit positions. So I think it is kind of important that you put in the zeros in the correct order. All right, so for part two, it's VU instead of VS. Okay, so that would be 0 plus 2 plus 0 plus 8 plus 0 plus 2032. So that would add up to 42. There we go. And then C2 of X, okay? Once again, show your steps. So in this case, C2 of 101010 in base 2 is C1 of the same bit pattern, the whole thing plus 1. C1 is logical, no, bitwise not. So that would be it would turn all the ones into zeros and all the zeros into ones. And so it would be this one thing, this plus 1, which is 0 1 0 1 1 0 in base 2. Is that okay? All right. So in the exam, I cannot answer questions like, oh, what is that plus with a circle around it? Or how do you define C2? Okay. I cannot answer any one of those questions because anything that has to do with definition and what the symbol means, is implied that you already know it, or at least you know where to find it, and you bring the material with you. That's the whole point of making this open book and open notes. All right, so the next one is what is the VS of CS26? Okay, so VS of 0 1 0 1 1 0 in base 2 is 0 plus 2 plus 4 plus 0 again plus 16 plus 0. Oh, excuse me, minus 0, okay? Because the most significant bit or the power of 2 corresponding to the most significant bit is subtracted. So that means, okay, there we go, minus 0. So now this whole thing is, what, 6 plus 16, which is 22, okay? And then part 5 is consider a 6-bit binary addition, x plus y. What is the bit pattern y so that VUY6 is the least value that results in K6 being a 1? Show your steps to figure out the bit pattern. All right. Yes. Mm-hmm. Well, there are many, many ways to do this. The key is you have to show me the steps. So, so you can go with what does it mean when K6 is a 1? K6 is a carry bit. So when the carry bit is a 1, it means, I cannot represent the single digit addition of the digit right before that. Okay, so that means, we ran out of values, okay, to represent. But we want y to be the least value that's causing this to happen. So this is a 6-bit number. So from one perspective, you can ask, what is the largest value that a 6-bit number can represent as an unsigned integer? Okay, what would that be? And that would be a value of, and in base 10 it is, come on, you guys can do this. It's 2 to the power of 6, the whole thing minus 1, which is 63. That is correct. Okay, so that makes 64 just one value over, right? So you can now say, okay, 64 is the maximum of what a unsigned number can represent. Okay, it's just one pass. Okay, 64 is the smallest value that VUY6 cannot, whatever this number is, we'll just call it S here for some, cannot represent. Okay. Okay. So that means, if I add the VU x6 to VU y6 and I come up with 64, that would trigger a carry. Is that making any sense? So now we go like 64 minus VU x6 is, well, we computed VU x6 in part 2, so that would be 64 minus 42, which is 22. So that means if VUY6 equals 22, then K6 becomes a 1. Oops, becomes a 1. So now you have to go kind of backwards and ask, what is the bit pattern of Y in order for VUY6 to be 22? We just computed that a little bit earlier. Yep. So that would be, so Y has to be 1 0 1 0 1 1 0 in base 2. And I'm just gonna, because I ran out of space. That's one way to do it. Okay, there are many other ways to do the same thing. Yep. 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 Mm-hmm. Oh, okay. We just timed out. Yep. So whatever you do, you have to explain it. Okay, you have to explain it, and okay, come on. K row minus X. But how do you know that's the smallest value? So you have to explain to me why that is the smallest value that can make it overflow. Well, not overflow, but to make the carry bit a 1. Well, you have to explain it, and it has to be explained in a way that I can accept. So, number 6, consider a 6-bit binary subtraction. So this time it's a subtraction. We're subtracting z from x. What is the bit pattern z so that VSZ6 is the least value that results in the overflow of 1? Show your steps to figure out the bit pattern. So kind of the same thing, okay? Because we know that VSX6 is negative 22. So what we are really asking is, what is negative 22 minus z such that the actual value here is just outside of the range of what a signed 6-bit number can represent. So one way to answer this question is to first come up with the range of value that a 6-bit signed integer can represent. So what would that be? Okay, so on one side, so I'm just going to write this down here. So VS Z 6 has to range between, has to be less than or equal to 31, but it has to be greater than or equal to what? What is the most negative value? Negative 32. Okay, and that's coming from certain equations or formula that we have already talked about in class. Okay, so that means we want the subtraction to go over one side or the other side. So what do you think this is going to be going over? Is it going to be going over the side of the subtract of the negative side, or do you think it's going to going over? It's going to be going over the positive side. Has to be negative side. So we are looking for something that will give us negative 33. Does that make sense? So in order for something to give us negative 33, which is just outside of the range of what a signed 6-bit number can represent, so now you just have to figure out what is z in order to make this happen. So z is 11. So this implies vs z6 is 11, which then implies z is 0, 0, 1, 0, 1, 1 in base 2. Yep. So you have to show me the reasoning, okay? You have to show me why you think this is the bit pattern and then do the derivation. The bottom line is you have to really understand how numbers or integers are represented, signed and also unsigned. You have to know the range of values. You have to know what is overflow and what is the carry bit. What do they actually mean? All right. So I think that's the end of question number 2. Yep. Okay. Moving on to question number 3. So question number 3 is saying that this is a base 8 addition. What is the decimal representation of the value represented by the y row? Okay, so that's a pretty easy one. So that's 4 times a to the power of 0 plus 5 times a to the power of 1 plus 1 times a to the power of 2, which is 4 plus 40 plus 64. And that would be 108 in base 10. But you have to show me the steps. Okay, so people who do not show me the steps will not get full points. Number 2, which has its own little subpoints. Okay, so number 2 says start with figure out the related definitions. This part must be correct for the following parts to be scored. Okay, so for 5%, what is C of UW for base 8? Yep. Mm-hmm. Yep. And then the next one is the R definition, which is a single digit sum definition. And what would that be for base 8? Yes. Yep. U plus V, not W. Okay, I used the wrong letter here. That's supposed to be V. The whole thing, odd 8. Okay. Number 3, how is SI defined in this context? This is the same as R of QI, KI. Q of I is defined as R of xi, yi. K of I plus 1 is C of xi, yi, or C of qi, ki. I mean, this part really do not need to be copied or taken a picture of because that's what we have been working with for some time now. Yes. Huh? Um, yes, we are still recording. Yep. All right. So I have to be brutally honest. For part two, subparts one to five, it's me giving you basically 3 points because there's nothing about understanding, there's nothing about processing. This is basically just asking, did you read my notes? Did you take some notes in the class? That's all I'm asking. Okay? I need to say that, okay? Because if there are people in this class, hopefully there's none, looking at question number, part two, subparts one to five, and go like, I have no idea how to answer those questions, then I'll be asking, have you been studying? Have you been reviewing the material? Have you been paying attention in class? Because if you have done any one of those items, you will be able to answer those questions, or at least know where to find those answers. All right, so now moving on to number three. So we need to figure out all of these rows. Oh, this is the fun part. So the fun part is knowing only the Y and the Q row, and also K0 is assumed is zero in this case. This time it is given to us. So can we fill in the rest? Okay, so we'll fill in the easy ones first. Okay, this one is easy. Okay, and that's about it. Huh? Say again? For X? Well, we'll try to figure out that one by one. Okay. So we'll look at this Q of two, or Q0 being two, and ask, can we go backward to figure out what is X0? Now, obviously, exclusive OR is not going to work here because it's not in base two. Okay. So now the question is, how do we do this? It's it's all based on the definition of the R function. Okay, it's all based on the definition of the R function because what we are really asking is x0 plus 4, the whole thing mod 8 is 2. In other words, what added to 4 mod 8 will give us a 2. Okay, 6 is 1. Okay, now, technically, there's an infinite number of value that can do that, but of all of those infinite possible values, only one is within the range of at least zero, but not eight, less than eight, and six is the only answer that can fit that bill. So K1 has to be a 1 because 6 plus 4 is greater than or equal to 8. Okay, so that means S of 1 has to be a 0, which also means your K of 2 has to be a 1, which automatically means S of 2 is a 3. And okay, well, I mean, that part is pretty easy. So now we have to look at X of 1. Okay, so what plus 5 mod 8 is a 7. That was just a 2. And then the next one is also super easy. 1 plus 1 mod 8 is the only thing that can end up with a 2. So now we just have one more to do, which is k of 3. 1 plus 1 does not have a carry in base 8. 2 plus 1 does not have a carry in base 8. So this is going to be a 0. Are we doing okay so far with this? Okay. So the bottom line is all of these questions are really just testing, you know, do you understand how the digits relate to each other in a multi-digit addition? Okay. How each digit relate to all the other digits have been gone over many, many times already. Okay. So we just have to figure out what is part four. What is the decimal representation of the value represented by the S row? So that'll be 2 times 8 to the power of 0 plus 0 times 8 to the power of 1 plus 3 times 8 to the power of 2. So that's 2 plus 0 plus 192, I think, for a grand total of 194 in this case. All right, but this is not the scope of your exam because the scope of your exam is going to include Guess what? Doubles. But to understand doubles, the previous lab is kind of a pretty good introduction. So, the exam is only going to break it into even smaller steps, and it can go in either direction. Okay, so I can give you a value, and then you have to figure out step by step what is the hexadecimal representation of the binary arrangement of the bits, or I can do it exactly like what the lab is doing, give you the hexadecimal representation and ask you what value the underlying double is representing. So I can give you one or the other, or some additional forms that I have not thought of yet. I never ask the same kind of question twice. So it does get interesting over the years. It's like I have used every single possible way to ask questions about this topic. Wait, there's a new way to do it. So how do you prepare for a test like this? Yep. So the way you use the practice exam is not so much to remember or memorize all the steps involved in to answer the questions in the practice test. The practice test is a good way to understand the scope, maybe. Okay, what do you need to understand to answer the questions? But I would not memorize the steps in the practice exam and expect your exam is just a replication of the steps with different values. Okay, yeah, I would definitely not make that assumption. Okay, any other questions? Yep. Question number four. Is there a question number four? Yep, there is a question number four. Great. Okay, I forgot. Okay, so question number four is okay, this is a double representation thing. And this time I give you a value. You have to tell me what is the binary representation in hexadecimal format. Oof, okay, so what is the value of x63? It's going to be a 1 because VDX is negative. There we go. For part two, convert the absolute value of z in a mixed fraction f. Okay, so that is 21 and 5/8 here. Okay, this one does not ask you to show the steps, so you can just answer with a mixed fraction. Did you guys know what a mixed fraction is? Improper fraction? Okay. Okay, 20. Convert f into a binary number p. Show your steps. Okay. So, okay, so where is f? Oh, right. So it refers to the part from number 2. So now we say 21 and 5/8 is. So the way I do it, okay, this doesn't have to be the same way that you do it, but the way I do it is I break it up into powers of 2. So 16 plus 4 plus 1 plus a half plus an eighth. Okay, so that would be my first step. Then I convert everything into a power of 2. So that would be 2 to the power of 4 plus 2 to the power of 2 plus 2 to the power of 0 plus 2 to the power of negative 1 plus 2 to the power of negative 3. And then once we get to this point, you can just go one more step to kind of put everything into a binary number. So that would be 1, 0, 1, 0, 1.101 in base 2. Okay, so the way this works is this is digit 4. Digit 3 has nothing here. Digit 2 is here. Digit 1, there's nothing here. Digit 0 has a 1. Digit negative 1 has a 1. Digit negative 2, there's nothing here. Digit negative 3 is this one over here. So it really just goes back to base conversion here, which then relies on, how do numbers represent values? Okay, so it really is just about that. All right, so the next one is number 4. Convert P, which is the previous step, in binary scientific notation in the form of m, which is the mantissa, times 2 to the power of some exponent e. Okay, so that's the restriction. Okay, your mantissa has to be between 1, has to be greater than or equal to 1, but it has to be less than 2, but it has to be in base 2 as well. Okay, so that means if we're looking at 1.01010, 101 in base 2 times, oh, I have to show my steps. Okay, so I'm going to say shift the point how many times? 4 times, right? To the left, and in each time, increase the exponent of 2 by 1. Okay, so there it is. So you can do a sanity check. Okay, you can do a quick sanity check to see whether you did the conversion correctly. You just look at this one and you ask, what is 1 times 2 to the power 4? 16, right? So is this number greater than or equal to 16, but less than the next power of 2? The answer is yes. So it passes that particular sanity check. If your sanity check is about, did I get the exponent right? That would be the question to ask. All right, number 5. Compute the biased exponent of 2 and call that g. Explain your answer. So g is just the exponent of 2, which is 4, plus the bias amount, which is 1023, and that would make up to 1027. And that would be, oh, that's it. That's all we need because this one does not ask you to convert it into base 2. It's the next question. So the next question is to convert 1027 into a binary number. So now we say 1027 is 1024 plus 2 plus 1. Whoops. Uh, 2 plus 1. So that would be um, 1 followed by 10 zeros. But we only have 8 after that because we need 1 1 at the end. So 1, 2, 3, 4, 5, 6, 7, 8, 1 1 in base 2. There we go. All right, so part 7, assemble all the bits of X and explain where the bits come from. And you can use 0 dot dot 0 notation, but then you have to indicate how many zeros are included in that notation. All right, well, that's just saying this one goes here. And then we have the exponent, which is this part here. The biased exponent goes here, which is 1 0 0 0 0 0 0 0 0 0 in base 2. And then we have the fractional part of the mantissa, which is this part here that goes next, which goes here, which is 0 1 0 1 1 0 1, and then the rest are all zeros. So now the question is, how many zeros are in the notation of 0 dot dot 0? Well, just have to figure out how many are already spelled out. The rest of the 64 bits are included in the 0 dot dot 0. So you just have to count. This is 1, this is 11, so 12, and there are, what, 7 here. So 12 plus 7 is 19. 64 minus 19 is what? 45. So there are 45 bits here, 45 zeros. There we go. Yep. You can also quote the letters too, right? Because each one, you can also name it, like x63 is a 1, and you can then name the range of bits where the exponent is supposed to go. 1, comma, 4, comma, 6. Yes. but the order is not right because it would be 1, 4, 6. 1, 4, 1, 6, 4. Yes. But then 4 is tricky too because 4 gives you there are actually 1, 2, 3, 4, 5, 6, 7, 8 digits here, but the 1 point is implicit. So you still have to explain to me that that 1 point is not a part of the actual bit pattern. Yep. Yep. All right. So number 8 is just kind of bundling everything into a hexadecimal number. So you just look at this as 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, and a bunch of zeros over here, and then break it up into groups of 4. Look up the table. This is a C0 3, and that's a 5. That's A, and then the bunch of zeros down here. Uh, it should be 16 digits altogether. 5 are already spelled out, so there are 11 zeros here. That will be the answer. All right. Well, since the previous semester is using this particular format, you can also count on your question is not going to be in this particular format. Yep, go ahead. The question is asking, assemble all the bits of X and explain where the bits come from. And X is the bit pattern. X is the entire bit pattern, which is 64-bit wide. Why would it be more than 45 zeros? Because the whole thing has 64 bits, and we have spelled out how many? Yeah, we're counting the number of digits that are not accounted for. Yep. Okay. All right. So are we doing okay so far? Okay. And we still got 20 minutes remaining, more than 20 minutes remaining. Yep. Probably not with the transistors. Hmm? Give me ideas. Give me some ideas. Yeah, give me some more ideas. But these days, there's Chat GPT. I can upload this and ask Chat GPT, how can I cover the same material but ask the questions in a different way? That may not be a bad idea. Then I'll make sure that I don't use those questions because I know you guys would be doing the same thing and already get the answer from your Chat GPT. So I'll do exactly not that. Oh, I did not expect you guys to do anything. I have no expectations. It's not low, it's not high, it is non-existent. Yes. Depending on the distribution. So, for people who are new to my classes, I depending on the grade distribution, because I would plot it out. If it is reasonable for me to go like, okay, this class has about 40 something students right now, maybe 45, 46. So I'll just take the 90 percentile, okay, score, and if it is reasonable to do so, that score becomes the new 100%, and I just rescale the whole class based on that. So if I did that, that means 4 people would get more than 100%. because the fifth highest score becomes a 100%. So everything else is going to be scaled accordingly. So that means there will be four people getting more than 100%, and everybody else is going to get scaled up the same way. The person who got a 0 point to begin with will still have a 0 point, unfortunately, in that case. What? I don't understand what you mean by that. Collectively fail. Well, to do that, you require the cooperation of everybody else, and there are definitely more than five people in this class who goes like, "You guys just go for that plan," because it will make it an easy A for me to get in this class. You guys just go for the minimum. You cannot know. It's student privacy. That's why we have student privacy, so that you guys cannot bully the people who decided I'm just gonna try my best. Hmm? So for those of you who are gonna try your best, just look really sad. And it is actually natural. You just show your sadness for the rest of the class. Yes. I will look at that, and that's why I preface everything to as I will look at the distribution of the score of the class. If I see something that's suspicious, I'll just refer you guys all to student discipline, like the whole class. Yeah. In fact, I'll just invite student discipline officer over here so that to save you guys a trip. Yes. Yes. All right. So this is also important. So joking aside, this is important because with every test, somebody's gonna get kind of like, oh man, I totally bombed the test. Well, it happens. Okay, for different reasons, some people will not get the score that they want. So the question is, how does that impact your actual grade of this class? So this goes all the way back to the grading part. Okay, so the first thing is you can see this part already. All the homework assignments and all the labs only add up to 20% of your final score. Okay, in other words, missing a whole lab is not that big of a deal from the score perspective. But from the perspective of you did not get a chance to practice the stuff that you have learned, it is kind of a big deal. We are looking at the first exam, which is 20%. The next exam, which is about 12 at week 12 or 11 or so, is another 20%. The final exam is 40%. Okay, so now you look at the actual breakpoint of these scores. Okay, so we look at, let's see here. Where did I put that? It's somewhere around here. Okay, there we go. Um, let's see. So the actual breakpoint is here. So I don't think anyone is going to complain if I say for people who get less than 12.5% of all the possible score, they're going to get an F. I don't see anyone complaining. Yes? To get. Mm-hmm. Well, why do you ask me that question when you can figure it out yourself? What? Yeah. So you can see the percentages of each part is already listed here. So you can definitely look at those percentages and decide, okay, what do I want to start with? Which is always a strategy when you are in an exam, is to look at all the questions and see which one you think you are the most confident about and start with that one. And make sure you time yourself. If there are four questions and you have 80 minutes, that means on the average, you probably want to give yourself about 15 to 18 minutes so that you have a little bit of time left behind so you can go back to some earlier question. Yes, go ahead. Yeah, that one does not because all the individual parts carry equal points, so there's no need to kind of show the actual point value. Yep. Yes. Yes. So that means I cannot entertain any suggestion of, since we're not doing anything with the lab time, can we extend it through the lab time? The answer is no. Okay. But it is fair. It's applicable to the whole class. Okay, so it's not going to be like, oh, for you, I like you, so you can extend that time to the lab, but you cannot extend it. Nope, the whole class cannot extend it. So plan accordingly. Okay, I think with the 90 percentile, rescaling, even if I make the test a little bit too hard, it will still be kind of equalized, to a certain extent. All right. So, but I do want to show you this. Okay, because to get a C, which is what you need to pass the class, is 37.5%. Okay, it is not a whole lot of percentage. Okay, now, all of these are based on GPA. In other words, when I score, I also score based on GPA. Okay, I look at every single question. I look at every single criterion for each part of the question, and I ask, is this an A answer, a B answer, a C answer, a D answer, or an F answer? So that's why I can use this particular way to score everything. Yes, go ahead. It is for everything other than homework assignment and the lab, because the lab is just really adding all the points. So that's why, um, I think most people should get, if not all 20% of all the labs, they should get at least 18% out of the 20% of all the labs because they're so easy. Okay, because you can retry at least multiple times. Um, yes, there was a question, there was a hand a little bit earlier. Yep, go ahead. It's just that one because for that one I cannot hand generate a lot of test cases. Go ahead. Um, so the point of that particular question is to help you with the next step, because now you have the whole number part and then the fractional part. The whole number part, you break it up into a sum of powers of two, and then the fractional part, you do basically the same thing. But to have a clean break between the whole number part versus the fractional part helps remind people this is the non-negative powers of two. This is the negative powers of two. Go ahead. We are not going to have a lab on the day of the exam, but for people who want me to go over the answer of the exam, I can use the lab time for that purpose. But we may not be doing it in the lab so that the lab technicians can go home a little bit early. Yep, go ahead. Say again. I cannot catch the question. Um, I think you need to have a C or better to pass, quote unquote, pass a class. But depending on which program you're transferring to, it can be competitive, which means there's no guarantee of what GPA is actually needed because they will only determine once they have all the applications. There was another question, I think. Yep, go ahead. Yeah. Uh-huh. If you have 62.5% but less than 87.5%, that's a B. Yep. That is correct. Yep. No, it's 1 hour and 20 minutes. So we have 80 minutes, 80. Go ahead. For the final exam that you can work on, I can give you guys some more. Okay, I can give you some more, and some of those have mechanically generated keys as well, so I don't have to go over in class because I don't want to spend class time to go over the answers to the additional exams that I give you because I still need to move forward to additional topics. Okay, okay. One thing you can also do is to ask, Chat and GPT. So, have I shown you guys how to use Chat and GPT with the content that we have talked about? Yes. Mm-hmm. Okay, so let me look at the time. Okay, we're almost out of time. I need to give you guys the key of tonight's lab. There is a lab tonight. Just when you think tech did not cover new material today, there must not be a lab tonight. Aha. But we did cover some material that we have not had a lab on yet, which is the NC and PD stuff. So we do have this lab tonight, and you guys are gonna hate it. Okay, you guys are gonna hate it if you don't know the concepts. Okay, if you know the concepts and you know the process, of what is PD and what is NC, this one I would say is pretty easy because I think we might have covered a portion of this in the class already. So it is about whether you understand, how do we track changes in a circuit that has logic gates. So if the concept that we talked about on Tuesday is fairly clear to you, and also, okay, and also there are some additional, stuff that you can read here. Okay, so you can read tracking change propagation, which is a very short module, and the only thing it does is to talk about, how the NCPD stuff works. Um, so there are some additional material that you can read if you want to, but basically it is just based on the lecture on Tuesday. There's nothing else you really need to know to do this lab here. Yep, double. Yes, yeah. So double is the last topic included in exam one. That is correct. Yes. Oh, right. Okay, I forgot. I cannot remember that either. Let me track it down. Go ahead. Is Tuesday's lecture what again? Tuesday's lecture. Oh, you mean the recording? If it's not, I can upload it now. Let's see. What was the question? Oh, right, the access code. Yeah, this one is slightly different compared to the other ones because I was experimenting with the new quiz style from Canvas. It sucks just as badly, if not more. Step Master. It's Step Master because we are tracking the steps of signal propagation. Yes. Huh? 820? No. Why would I do that? Because I need to have captive audience in the lab.